Hi everyone, it's Evan Roti here from Amazon. Welcome to today's webinar. So I'm just going to hang on for 1 minute more as I'm seeing quite a few people still joining. Do stay with us for just another minute, and thanks for joining our webinar today. As we're waiting for people to join, the format of the webinar today will start with a presentation. And I'll try to make that around 45 minutes to 50 minutes. And then we will open for questions later on as well. So you can actually ask questions in the text box function, and we have some of my colleagues standing by as well, taking down your questions as they come in. So please do ask any questions that you have in the text box. So we'll just get started in a minute. All right, so I think we'll get started today. Again, thanks for joining this webinar from Amazon Web Services. My name is Evan Roti, and I'm a solutions architect with Amazon. I'm based out of our Singapore office, working in Asia Pacific. And today we're going to talk about lowering costs and increase agility with AWS. So for those of you who just joined, we also have a text part of this webinar, so you can put in your questions there, and my colleagues will be able to help you and answer your questions, and we'll also take a few questions at the end as well of the webinar, depending on how quickly we get through the material. So without further ado, let's get started. For many of you, you are probably quite experienced with AWS already, but just as a quick repeater before we go into the topic of today's call, let's just review the Amazon Web Services infrastructure. So at the very bottom of your slide, you can see that Amazon has our global physical infrastructure. So we have geographical regions. At the moment, we have 9 geographical regions, and regions are collections of availability zones or data centers. Of special interest to many of the people on the call today, we actually recently launched our Sydney-based data centers as well. So that was our 9th geographical region. Building up this stack of globally distributed infrastructure, we have some of our low-level building blocks and core functionality. So first of all, we have compute. So compute includes one of our most popular services, Amazon Elastic Compute Cloud, EC2, and also auto-scaling that allows you to dynamically scale your infrastructure on demand. So EC2 allows you to run Windows and Linux, and you have full control over those machines. From a storage perspective, we have a wide range of services. So we have Amazon S3, which is the simple storage service, which is basically your unlimited hard drive in the cloud. You can put any object on there. And we also have block storage like EBS. Elastic Block Store allows you to put and mount disks onto your virtual machine. One of our more recent services is called Amazon Glacier, and Amazon Glacier allows you to archive your storage, archive your backups for long-term retention, and it starts at a very, very low price, so 1 cent per gigabyte per month. From a networking perspective, we have the Amazon Virtual Private Cloud that allows you to create an isolated network inside the Amazon cloud so that you have full control over your subnets and your networking. And from a database perspective, we have a wide host of different services, including managed databases, like our relational database service, and also NoSQL or non-relational databases like Amazon DynamoDB and Elasticache. I have to apologize as well. I've got a bit of a cold at the moment, so sorry if that's of inconvenience. Above the low-level building blocks, we have parallel processing, data transfer, content delivery, messaging, and search services. So many of you will be familiar with things like Hadoop. So Elastic MapReduce offers Hadoop as a managed service. And we also have things like Amazon CloudFront that allows you to cache your content close to the end user's location. At the very top of the stack, before we get to the applications, we have some more services. First, I'll talk about the cross-service features. So we have things like CloudWatch, our monitoring tools that allows you to monitor your services from a central monitoring position. We also have an integrated identity and access management service that allows you to control user access. And from a deployment and automation perspective, we offer several services that gives you the opportunity to manage your infrastructure as software. Then at the top of the stack, we also provide multiple libraries and software development kits. So if you program in .NET or Java or Python or Ruby, we offer, as well as mobile kits like Android and iPhone. We also offer you libraries and SDKs for that. And we have plugins for popular IDEs such as Eclipse and Visual Studio. And of course, you have a web interface that allows you to control all of our services and command line interfaces as well. Very, very importantly, when it comes to AWS, our strategy of pricing each service independently gives you a lot of flexibility to choose the service you need for each project. And importantly, you pay only for what you use. So you pay as you go, and you also pay less per unit when you use more. So we'll talk about that in a moment. You pay even less when you reserve, and even less again as AWS grows. So I'll be covering some of these important points with you as we go along into the presentation today. I work with a lot of especially our enterprise customers, and again and again, most of my customers, they always want to look at the total cost of ownership of a solution, and they want to compare the total cost of ownership of on-premise with the AWS services. So it's very important when you do this that you compare apples to apples, not apples to oranges. So when calculating TCO, start by understanding your use case. So it's very important that you understand your own environment, your own use cases, and the applications that support them as well. So the first thing you should do is to analyze and understand and classify your IT assets. So most enterprises have a lot of different applications and interdependencies between them. So what we recommend is to start classifying your assets into different categories. For example, application with top secret or public data sets, as well as applications with low, medium, and high compliance requirements. You can also classify applications by internal only, partner only, or customer facing. That's another way. And when you talk about the coupling between applications, it's often useful to classify applications between low, medium, and high coupling, let's say. Of course, you have to define a good metric for that as well. Finally, some point that is often forgotten is around licensing. So you can also classify applications depending on what kind of licensing requirements the software vendor has for that. So once you started classifying your IT assets, you can then rank your IT assets. Okay, so you can put them in a stack and you can rank them. And what I would recommend you look for are underutilized IT assets. Excuse me. So a lot of the IT assets running in your data center currently are heavily underutilized. And as we'll see later in this presentation, AWS and the elastic nature of AWS can really help you to get the most out of your assets in AWS. Also, if you have applications that have an immediate business need to scale, AWS provides you near limitless capacity so that you can scale to handle the load that's required. And we'll talk about that in a lot more detail. A lot of my customers also have applications that are running out of capacity, so that's another good point to consider cloud computing on AWS. And also consider applications that are easy to move today, so applications that are easily adoptable to the cloud. I think of the journey to the cloud as just that. It's a journey. So if you manage to get some first early successes, that will help you to build support within your organization, create awareness, as well as excitement. So I think it's very important to choose those critical early projects carefully. Spend the time actually finding that out. Let's talk a little bit about usage patterns as well in applications, because not all applications are created equal. So I've got 3 examples up on your screen at the moment. So the first one is what I would call a steady state usage pattern. And steady state usage pattern, examples of that might be data logging. So these are steady state, not a lot of variety in terms of processing requirements. So it's pretty predictable. Then we have what I call a spiky predictable workload. So for example, a marketing promotions website. So as you can see here, the graph shows that there's a big spike in there, and maybe that's during a marketing promotion, but it's predictable. You know that a lot of people are going to come on for those days because you're promoting it and it's part of a marketing campaign. So that's why I call it spiky predictable. A third one is called uncertain unpredictable. So these are applications where you're really not quite sure what the volume and the load is going to be on the site. So an example there might be web apps. And in terms of web apps, you might be very successful and get millions of users to your web application, or maybe you're not as successful and you don't get many at all. So it's difficult to predict, but we'll talk about how AWS can help in all of these and many more. In terms of choosing your first application as well, pick the low-hanging fruit first. If you pick the low-hanging fruit, you can then learn from that. So in this case, maybe we take one of the applications out, and that becomes the first initial project. And it's critical to understand that through that project experience, your team and your organization will learn a lot about AWS. So that low-hanging fruit in the beginning just enables you to fight your battles as they come up. So when calculating TCO, start by understanding your use case. So that's very important, step number 1. On to the next step. So as I mentioned earlier, when comparing TCO, it's often very difficult to get an apples-to-apples comparison. So it's very important when you do these calculations that you take all the fixed costs into consideration. So don't forget a lot of the hidden costs involved in it. It's all too easy to just look at the superficial cost of an on-premises application. So to help with that, we have other parties as well, for example, Gartner. So Gartner, this is a screenshot from a Gartner benchmark analysis. And you can see here it points out many different aspects of TCO. Now, most people will be aware of the top of the stack, hardware and software. But how about connectivity? How about your connectivity between data centers and internally in your data center, so the networking? Have you taken that into account? And that is often a very difficult part of the solution to cost for, because it's a shared infrastructure. It's shared amongst many applications. So how can you divide up that shared infrastructure? Disaster recovery. So disaster recovery costs are very important to take into account as well. And the bottom 2 are probably the ones that I've noticed are most often missed or underestimated in TCO analysis. First is the facilities cost. So from a facilities cost perspective, you have things including the power and the heat management, raised floor, and office space. So all of that should be taken into the account when calculating the full TCO. Personnel cost, including technical support, planning and process management, and administration. That's often a very large part of the total cost of ownership, but is often ignored or simplified because it's very difficult to quantify it exactly. So if we create a fictitious scorecard, so this is a very high-level scorecard, but this kind of table might help you identify the different factors. So what we've done here is that we've identified the normal relative weighting of the costs of these different factors. So we've compared AWS to collocation and on-site. And in the first column, you have one-time upfront cost. So this is the fixed upfront cost that you have to pay. And then you have monthly cost after that. Now, not surprisingly, you'll see that AWS for the upfront cost has, zero in most of those pockets, whilst the on-premise and colo costs have costs indicated there. From a monthly cost perspective, AWS certainly has a monthly cost, it's pay-as-you-go, and colo and on-site has as well. So this kind of table might help you identify different areas, and you put assumptions in to talk about, how much you think the different areas actually impact your application when you're comparing. So this is a more holistic way of looking at it. So when we look at some of these, like hardware administration cost, so personnel costs include, the cost of the sizable infrastructure teams that are needed to handle the heavy lifting. So managing heterogeneous hardware and related supply chain, staying up to date on data center designs, negotiating contracts, dealing with legacy software, operating the data center, moving facilities, scaling, etc., etc. So these are, things that an enterprise needs to do well if it wants to achieve low infrastructure costs in the areas discussed above. So I won't go into a lot of detail in each of these. I think the important thing is to capture all of them in your TCO analysis and go into depth and put realistic assumptions around it, okay? So that you don't overlook costs, including in the data center planning stages, for example, as well. So let's get back to the different points you need to take into account when calculating TCO. So the next thing I wanted to talk about is to always be up to date on our pricing, okay? So use updated pricing for your compute, for storage, for network, and be aware of price cuts, tiered pricing, and volume discounts that are available. So first of all, massive economies of scale and efficiency improvements inside Amazon Web Services allows us to continually lower prices. And we've done that 20 times since we started. So the other key here is automation. Because of that scale, we're able to automate, pretty much all of the processes that we have. And some of our customers, we love getting feedback from customers, especially customers like this. So this is a CIO of a Fortune 500 company, and he's talking about how, he looks good in front of his CFO when the CFO sees the savings in the AWS monthly bills. Okay, and that's exactly what this webinar is about. We're going to show you a few of the tips and tricks that you can use to reduce your spending and optimal, get optimal usage out of your AWS resources. First of all, let's talk about volume. So you can pay less when you use more. So I've given some examples here in terms of storage pricing, data transfer pricing, and also reserved instance volume discounts. We'll talk about reserved instances in a moment. But as you can see, and these are all from our public pricing website, as you can see, as you use more data, so for example, storage pricing here, you can see it starts off with first terabyte, next 49 terabytes, 450 terabytes, etc. The more you use the service, the lower the cost per gigabyte becomes. So you pay less when you use more. So that's very important to keep in mind as you are creating your TCO analysis. It's not just a fixed price. The same is true for data transfer, okay? So as you know, all data transfer into AWS is free. We don't charge you for data transfer into AWS. And when you transfer data out of AWS, we charge you less per gigabyte when you are using more, okay? So the more you use, the less you pay. Then let's talk about, incremental adoption savings. So in terms of storage, this is a graph of a potential storage usage in terabyte over 36 months. So, excuse me. So over these 36 months, you can see that you start off using 0 at the beginning, and then you add regularly more and more storage over time. So remember, you're only paying for what you use. So whilst if this was an on-premises solution, you might have had to buy up front a big storage solution to cater for the next 2 to 3 years. But inside Amazon Web Services, you're only paying as you go. So you pay for what you use. So you only start paying for, let's look at the 40 terabyte mark, you're only starting to pay 40 terabytes a month after 34 or 35 months in this graph. So you're saving a lot just in that incremental adoption. Okay? So if we, for example, wanted to implement this as provisioned storage, maybe on-premises or colo, you might have had to invest in, let's say, 20 terabytes of storage from day one. And then you would have to upgrade it again after 2 months. So you get this red line effect that's showing on your screen at the moment. However, the actual storage is being charged for AWS, so you're only paying for the stuff in the blue area rather than the red area up here. So you're saving a lot just in terms of incremental adoptions saving. And even more importantly, you don't have to have underutilization or waste, as you can see in this big red area here. So you can use your IT storage much more effectively and efficiently. Also, a lot of people forget that we have a lot of free usage tiers and free services. So, for example, the free usage tier, for new customers for a year, you can use quite a lot of our services, including our Compute Cloud and RDS, for free. Okay, and RDS is a new feature in there, and all customers have a free tier as well for SQS, SNS, DynamoDB, etc., as you can see on the bottom. Many of our services as well and features are free themselves. So Elastic Beanstalk, that allows you just to drop your application into a container and the infrastructure is built for you, you don't pay anything for Beanstalk itself. You only pay for the resources that you're using. Same with CloudFormation, that allows you to define an entire infrastructure in one template, or identity and access management, or auto-scaling, or consolidated billing. So all of these things come for free. They're included in the price that you pay for the resources. So I think that's important to keep in mind. And finally, we already talked about data transfers. So there's no charge for inbound data transfers, and even data transfers between instances within a data center, within an availability zone, does not cost either. So imagine all of that network infrastructure that is inside an availability zone. You're not actually paying for that. You're only paying for the instances. So those are some of the things to keep in mind when we talk about pricing and how we update it. Next, we'll go on to an area that I want to spend quite a lot of time on, because a lot of customers are very interested, but some are confused with this. It's reserve pricing and on-demand pricing. Excuse me. So reserve pricing and on-demand pricing, what it allows you to do is to amortize the cost monthly over 1 to 3 years. So by giving you multiple pricing models, it allows you to optimize costs for both variable and stable workloads. So we'll come back to some of those workloads that we talked about earlier, predictable and unpredictable. So we're going to talk about on-demand, reserved instances, and spot instances. So these are the 3 different pricing models for virtual machines. So the first type of instance is called on-demand instances. Okay? And for this type of instance, it's all pay as you go. And it starts from as little as 2 cents an hour. The price stays the same, and when you turn off your resources, you stop paying for the resources. Now, reserved instances is a little bit different. Reserved instances is a pricing model that allows you to pay one time or one low upfront fee, and then after that, you pay as you go. Okay? So, for example, in the example on the second bullet here, you pay $23 upfront for 1 year, but then your hourly cost is reduced to 1 cent per hour. Okay, so you pay an upfront cost, but then your hourly charge is reduced. You can choose reserved instances as either 1 or 3-year terms. And we'll talk about when you would want to choose both of those in a minute. We also have 3 different options: heavy utilization, medium utilization, and light utilization. And I'll go into some detail about that now, showing a graph. So first of all, don't be too scared when you see this graph. It's a little bit busy and it can be a little bit intimidating. But let's go through it in detail and have a look at what is actually showing. So first of all, it's showing an instance type, in this case an M2 extra large, running Linux. Okay. And this is showing a 3-year period. So on the y-axis, you can see the total cost over 3 years for that instance. And on the x-axis, you can see the utilization. Now, utilization means how many hours, in the day, in the month, are you using? Is that instance actually running? So it doesn't have anything to do with CPU utilization or performance. It's purely how many hours in the month are you actually turning on that instance? Is that instance in a started or a running state? Because remember, when you stop a virtual machine, it actually stops charging you. So if you, for example, are using your server all the time, let's say a production database server, your utilization will be 100% because that server is always on. It's always running. Every hour of the month, it's running. So that would then be over on the 100% side of the utilization. So that's what utilization means. If you have another server which is turned on 12 hours every day, 7 days a week, so you turn it on for 12 hours, you turn it off for 12 hours, that server or virtual machine has 50% utilization. So nothing to do with CPU utilization or performance, it's just the number of hours that it's turned on during the day. So why do we have all of these different factors? Well, it's because we want to give you options, pricing options, for many different types of workloads. So let's have a look at that. I'll leave this slide for a moment just to digest. So if you look at the utilization first, we have a couple of different types of utilization. The first one is less than 10%. So for less than 10% utilization, what kind of use case can you think of for less than 10% utilization? Well, it will probably be an instance that is used very rarely, if at all. So one way of thinking about it is maybe it is just a service that gets turned on once per night to maybe kick off a job, and then it stops itself again. So it's very, very low utilization. So if you have something less than 10%, in fact, the sweet spot, the best pricing mechanism for that is on demand. You will save more money using on demand for less than 10% utilization. And that also means you have no upfront commitment, which is great. The next one is a 10 to 40% utilization. We would then recommend using a light utilization reserved instance. And this is ideal for things like disaster recovery. So if you have a disaster recovery where you have a standby data center where you're typically not running your virtual machine, but you need to run it when a disaster happens, this can then save you a lot of money. So the upfront cost is very low, and the hourly charge is a little bit higher than medium and heavy utilization, but you're going to be turning it off most of the time, so you're not paying that hourly charge at all. So the savings over on demand can be up to 56% in this case, so significant savings just by getting a reserved instance. The other feature of reserved instance that I haven't mentioned yet is it actually gives you reserved capacity in that availability zone, which is exactly what you will want in a disaster recovery scenario. You want to make sure that you have reserved capacity ready for you when you need it. Let's go on to the next element, the 40 to 75% mark. So this is around halfway there. So we would recommend a medium utilization RI. And this is, standard reserved capacity. And this might be a very good use case for things like development environments. So let's say you're using the development environments maybe just during office hours and maybe not at all during the weekends. So this might be the best combination of upfront cost and lowered per hour pricing for that. You're only going to use it, turn it on 40 to 75% of the time. And you can see that can give you up to 66% savings over 3 years. So significant savings there. Finally, probably the easiest to understand, the heavy utilization RI. Heavy utilization RI is recommended for workloads with more than 75% runtime in a month. So this will definitely give you the lowest total cost and is ideal for servers that are running all the time. So you can save up to 71% over 3 years using heavy utilization RIs. The other important thing to note about heavy utilization RI is that you pay for the hourly charge whether the instance is running or not. Okay? So for those of you wondering why the graph for the red line, why that is actually a straight line, it's because it's running all the time. It's always charging you whether you're running the instance or not. Light utilization and medium utilization, we only charge you the hourly charge if you're running the instance. For heavy utilization RI, it's meant for being turned on all the time, so you get charged for the hourly charge whether the instance is running or not. Okay, so important to keep in mind. Let's go on and look at an example TCO of a 3-tier web application. So this is just an example architecture here with 3 tiers, a web tier, an app tier, and a database tier. So let's have a look at an example in there. So the first we're talking about is the steady state usage pattern. So in the steady state usage pattern, you can see that the usage is pretty flat, and maybe you need between 4 to 6 or 5 to 6 instances most of the time, but it's pretty predictable. So from a physical infrastructure perspective, you would probably need to, if you wanted to do it in your own data center or in a colo, you would probably have to draw one of these thick red lines. This is your capacity planning. So you would have to plan capacity at that level to make sure that you can handle all the normal loads and also the small peaks that you see in there. And in this case, in fact, reserved instances could be drawn at exactly the same line. So you can buy reserved instances for pretty much all of this because it's steady state, you know what the traffic is going to be like. So in terms of savings, you might be able to optimize your savings using reserved capacity there. So let's look at the calculation for that scenario. And remember, this is for a multitude of servers that we saw already, a 3-tier web application. So in this example, you have, and I'm just going to explain this table because we're going to talk about it in the different examples. You have the different types of costs, including server hardware, network hardware, maintenance, cooling, etc. And the total cost per month is listed on this line down here. So you can see the on-premises option in this example comes up to a monthly cost of about $1,900. And then we add up the cost over 3 years, and for the on-premises option, we then calculate that to be $69,500 over the 3 years. Now let's compare that with 3 options on AWS. So the first option is we go all reserved, so 3-year heavy utilization reserved instance for every single virtual machine. So remember, this is a predictable workload, and we set the reserved instance line at exactly the same time as the on-premises capacity line. In this case, you could see the only cost in here is the AWS instances, and the total cost ends up over 3 years as $22,260. Okay, over 3 years. So you can see the savings are significant over the on-premises option, in fact 68% less. And as you can see, it's the recommended option because option 2, which is a mix of on-demand and reserved, we'll go into that in the next example, is not as effective. It's not as cost effective as all reserved 3 years heavy utilization because of the predictable demand. And interestingly, option 3, which is to go all on demand for all the instances, actually is more expensive than on-premise in this example, $76,000 versus $69,000. So you can see you have to be very, very careful with what you want to implement and the pricing model that you want to use to get the real cost savings out. So you can see you can go from 68% cost savings to 10% cost increment just based on the pricing model that you choose. So it's very important that you think about and choose the right pricing model. So that's example number 1, the TCO of a steady state web application. Let's go on to a Spiky predictable usage pattern. So in this case, you saw this earlier. This is, for example, a marketing website that comes up during a campaign. So you know when the spike is going to come, so you can predict it. So in this case, again, if we were to have physical infrastructure, if you were to buy it yourself, you would probably have to draw a red line where? You would have to draw it up on top of the expected peak, because you need to handle the peak load on your website. So when you do that, you then have to buy, in this case, 10 servers or 10 instances to handle that load. However, what you can do in AWS is you can use reserved instances for the baseline. So here you can see at 4 servers, that's our baseline. We always need that. And then we can use on-demand instances for all the spiky workloads. So when we need those servers, we'll just spin up virtual machines to handle the work when we need it. Very important to note is you can turn off your cloud resources whenever you want. And when you turn them off, you actually stop paying for them. So this is a key point to understand for this predictable spiky workload scenario. So let's go through and do a TCO calculation for this. First, we have the same spreadsheet. You have an on-premise option and AWS options 1 and 2. But in this case, you can see that if you go all reserved, you still get a significant saving, but it's not as good as option 2. So in this case, option 2 is the recommended option because you get a higher saving, 72.6% in this case. Why is that? It's because you did the analysis and you set reserved instances only for the 4 instances to carry the base load, and then you used on-demand instances to do all the peak workload when you need it. After you finished your peak workload, you just turn off your on-demand instances and no longer pay for them. Okay? And you can see option 3 is commitment-free and risk-free, but it doesn't give you as much savings as the other options. So let's go on to some more complex patterns. So the first example here for uncertain, unpredictable usage patterns, I've got 2 lines. I've got a blue line, which is the actual traffic. So this is in hindsight, when we look back. This is what actually happened. So what actually happened was that we started off thinking and expecting, this is the expected traffic, that our product or our web service was going to become wildly popular and a lot of people would want to come and visit it. Unfortunately for us, though, the reality didn't turn out that way. So the actual traffic is far below what was expected. So, things didn't go out or wasn't as good as planned. So in this case, if you put the reserved instance up here because you were expecting the traffic to go up, that's probably a one way you could do it. You could put reserved instance at a very, very high level. It's also the same level that you would put your physical infrastructure because you're predicting the load and you have to look 3 years in advance for your infrastructure needs. But from an on-demand perspective, if you were running on-demand all the time, the on-demand, you would only pay for what you're actually using. And, well, fortunately for you, it means you're paying a lot less. Unfortunately, it means that your product wasn't that successful. So it's a kind of good and bad at the same time. But this brings up some very, very important points. The first one is in terms of light and medium utilization reserved instances. They have very low upfront one-time fees, and when you turn them off, you save on the hourly usage. So even though your product didn't go as well as it was hoped, you still have significant savings because you used light or medium utilization instances, so you don't pay the hourly charge when you're actually not using them, when it's not useful. So in this case, you would still have very, very high benefits or high cost savings using option 1, all reserved, or a mix of on-reserved and on-demand. But as you can see, in this specific case, on-demand actually turned out in hindsight to be the most effective from a cost perspective of all of them. So if you predicted failure, then you might have gone with on demand. But even if you went with light and medium utilization, you could save a lot by doing a combination of reserved instances and on demand. So you can see the difference isn't that great. So this is really a fantastic hedge against risk of your application. And I wanted to bring out a quote that I really like. This is from Joy Ito, or Ito Joy. Some of you might know him from from the Commons group. So he's a very, very prominent figure, especially in the Commons area. So he had a great quote that I like a lot. So he said that, if you want to increase innovation, you have to lower the cost of failure. And that's exactly what you can do here, and we encourage our customers to do is experiment often. So here, if you have a lot of great ideas, you can see the light bulbs kind of going off here. Many of those ideas will work out. They'll be very successful. However, some of them will fail. Some of them will not be successful. But by using AWS and by understanding, how to use reserved instances, light utilization, medium utilization, etc., cost of failure falls dramatically. So you can be free to try out new ideas without risking, a lot of money in failing. So that leads to more risk-taking and more innovation. And as you can see, the dollar signs here are typical dollar signs that we would see for proof of concepts. You can start today to do proof of concepts with this kind of money, and if it doesn't work out, well, then you at least tried, and you failed quickly, and it didn't cost you very much at all. So that's the silver lining behind this. With AWS, you can experiment often and fail quickly if it has to fail, rather than having to wait for years before the failure is experienced. Let's go on to another more positive scenario. Let's say you have an uncertain, unpredictable usage pattern. So again, the expected traffic, you could see you're expecting, growth over 36 months. But the actual traffic, so when you see the actual traffic is much, much higher than the expected traffic. So that's the blue line up here. In other words, you were fantastically successful, much better traffic and throughput than was expected. So what is the most cost-effective way to price in something like that in this scenario? Well, first of all, if you have a physical infrastructure, you would have probably done capacity planning and invested in hardware and infrastructure to support the peak maybe after 3 years of your expected traffic. If you do reserved instance, you would probably do the same thing. You would put your reserved instance green line at the same place as the physical infrastructure green line, physical infrastructure red line, sorry. If you did on demand, you would just be paying for exactly what you needed. So it would be growing over time, as you can see here. Starts off really slow, and at the end you have 40 instances running, way over the 16 that you predicted as your peak. However, the risk here, if you go on-premise, is you can have a lot of disappointed customers, because in this whole area here, the actual traffic is way above your infrastructure, what your infrastructure can handle. So potentially you risk disappointed customers, and there's a big risk that you can't scale quickly enough in here. You have to order new hardware that has to be delivered, you have to configure it, etc. So in that case, the cost of lost business or disappointed customers can far outshine any benefit from the original savings that you might have had. So I'd now like to introduce a new pricing model as well, in addition to on-demand and reserved instance. And we call that spot instances. So spot instances are instances where you request an instance and you have to put a bid price. So you actually bid for an instance. So the spot pricing here, spot instance refers to spot markets, where the price of an instance actually changes. So I'll show you an example of the spot market. So this is for an M1 large instance. And you can see the spot price actually fluctuating throughout these days. So most of the time here you can see it's around 16 cents per hour, but then it even spikes up to 20 cents per hour over time. So this is the spot pricing. So using spot prices together with on-demand and reserved, you can save even more money. Okay? However, there is one big thing you should be aware of with spot instances. So spot instances, you bid a price. So let's say in this case on April the 12th, let's say that I bid 19 cents for an M1 large. So I'm actually bidding far above the spot price. What would happen is I would actually get that instance and I would only be paying the spot price. So even though I bid 19 cents, I'm paying the spot price, which is lower than 19 cents. However, when we go over here to April 27th, the spot price goes up to 20 cents. And if my requested price, my bid price is still 19 cents, I now have a scenario where the spot price is higher than my bid price. What happens then is Amazon Web Services takes back that instance and gives it to the person who has a higher bid. So you have to be very aware that that instance can be taken away from you at any point in time. So it's very important to think about the correct use cases for Spot. So you want to use Spot for workloads where you can checkpoint often and save your work. Okay, so some examples are up on the screen at the moment. We see a lot of people using it for batch processing. So it adds capacity to your processing and you save often. So even if the instance is taken away from you, you can recover your work and continue working on demand or even with a higher bid. Hadoop, which is part of the big data services that we have, Hadoop allows you to do massive parallelized analysis of semi-structured data. Hadoop actually, and we have a MapReduce service, Elastic MapReduce, that is a managed Hadoop service. Spot is actually integrated into that service, so you can use it to burst your analysis if you want to finish your calculations faster. And in fact, with Spot, you can reduce both the processing time as well as the cost for the total job. So you can do it faster and cheaper by using Spot. So very, very, very powerful. Other use cases include high-performance computing, scientific computing, test and development, as well as any kind of cheap compute. And I'll give you an example as well of a specific use case in a moment. Well, bidding strategy in Spot seems to be very important then because it's really dependent on your bid and your spot. So there are a couple of different strategies, and here you can see a sample bid distribution. You can see that on the left side here, percentage of the distribution, this is how many bids were part of the x-axis, which is the bid price as percentage of on-demand price. So the bidding strategy here for 100% means I am bidding for Spot the exact same as the on-demand price for that instance. So if my instance is 8 cents per hour on demand, I will bid 8 cents per hour. And if the spot price is lower than 8 cents, I will pay that lower price. So you can see that is probably the most common bid strategy that people have. Many people actually bid less than that. They only want the spot instance if it's worth it to them. So they will only bid maybe 50% of the price. They only want that extra capacity, that spot instance, if it's half the price of on-demand. So you can determine how much you want it. And there are even some people who bid higher than the on-demand price as well. But remember, even if you bid higher, you still get the instance and pay the spot price. So the spot price will be the same or lower than your bid price. So a couple of different bidding strategies there. You can bid lower, you can bid exactly on, which is the most popular that I see, or you can even bid above the on-demand price. So remember I told you I'll give you an example. So Vimeo, this is a customer case study for Vimeo. So Vimeo was one of the first, true HD video sharing sites where people can upload their HD videos and share it online. And they actually have two offerings. They have a free offering that's optimized for reducing cost, okay? And what they do is they use Spot to give, acceptable delays when you upload a video. So they would use Spot instances to process your videos. If you've just made a video and you upload it, the transcoding process on Vimeo, if you're a free user, will, be acceptable, but it won't happen straight away. And it actually uses Spot instances in the background to keep their costs optimized. Okay, So their priorities there is to optimize for cost, not for performance. Then they have a premium offering, people who actually pay memberships to Vimeo, and that's optimized for faster response times. So they actually use reserved instances for the transcoding there, so that the transcoding happens straight away, so that their customers get much faster response times in there. So this is a common pattern where you can use Spot for a free offering, and for the premium offering you can use reserved or on-demand instances. So that was, we talked quite a lot about the different types of pricing models you have, reserve pricing, on-demand pricing, etc. And finally now, as the last part of this presentation, I want to talk about intangible cost savings. So these are things that are very difficult to put in an Excel spreadsheet and assume, make assumptions around the costs, both on-premise and AWS. So I wanted to cover this because it's very important you get this just by using AWS. So first, I wanted to talk about security. So when you use your services with AWS, you basically, with no extra charge, get a premium security spec at non-premium prices. So as hopefully most of you who have used our services know, we have security as our #1 priority. And we have certifications, including the ones listed here, and we manage physical security, hardware, software, and network security as well. So you get that, all of that stuff included in your service. You don't pay extra for that. So you get the benefit of security of a massive infrastructure company like Amazon for the low cost of running your instances. Reduced time to market. I think this is one of the most important benefits that you get, but it's difficult to quantify. But by running on AWS, you can get started today. You can build your product today. You don't have to wait, order hardware, get a CapEx budget to spend. You can get started today at little or no cost, and then you can either get to success quickly, do your POC quickly, or in the worst case, you can fail quickly. But if you fail quickly, at least you haven't spent a lot of money, you haven't spent a lot of time, and you can then move on to the next project and make that a success instead of having to wait for hardware to be delivered first and then only start on your project. So reduced time to market translates into more revenue. AWS allows you to focus on your business. So because we take care of the undifferentiated heavy lifting in our data centers and keeps that running for you, you don't have to spend your time doing all of that very, very low-level work. So you can focus on your business, and your IT staff, your highly skilled IT staff, can also focus on even more value-added activities. For example, helping the new project, rather than just keeping the lights turned on, rather than just operating the existing infrastructure. Also, through continuous optimization in your architecture, you can get recurring savings straight away. So if you optimize your architecture, for example, you deploy a version 1 of your infrastructure, and then you get a feel for the capacity that's needed, and then you start investing in reserved instances, you will see the benefit of that in the next month's bill immediately. So cost savings hit you straight away. You don't have to wait for a long time because you don't have all of that sunk cost. So optimizing your architecture for cost can give you cost savings immediately, as quickly as your next month's bill. So hopefully I've talked a little bit about comparing TCO and how it's sometimes tricky to compare apples to oranges. What I hope that you've gotten out of it is that you understand some of the considerations, some of the factors you have to put into the calculation, okay, and try not to miss out on a lot of the factors that are sometimes forgotten about. From a pricing philosophy as well in AWS, remember that AWS, our philosophy is pay as you go. So there's no minimum commitments or long-term contracts, and we turn CapEx expenditure into OpEx. So you can turn off your resources when you don't need it. That's very, very powerful. You pay less per unit when you use more. So this is the volume and tiered pricing we talked about. And when you use reserved instances, you pay even less. Now, even with all of these savings, as AWS grows, so as AWS becomes bigger, we translate efficiencies, optimizations, and economies back to you, the customer. So I already mentioned we've cut our costs 20 times since we started. So our pricing philosophy is to bring you, the customer, lower cost over time as we optimize and become more efficient because of our scale. We also have options for custom pricing. So custom pricing, if you spend a lot of or have a lot of infrastructure on AWS, we may even be able to do custom pricing for large purchases. Okay. So I'd like to introduce you as well to our Economics Center, AWS Economics Center. It's located at aws.amazon.com/economics. There you'll find TCO white papers. You'll find several calculator tools. And I'd like to highlight one of the more recent calculator tools. This is a TCO comparison calculator for web applications. So most of you who have used our detailed AWS calculator knows that it can give you, a very good estimate of your AWS expenditure, but it has a lot of detail that you have to put into it. Number of servers, utilization, how many gigabytes you need, etc. If you want to have a total cost of ownership comparison with on-premise and AWS in a quick, easy-to-understand manner, I highly recommend that you go to the TCO comparison calculator. You'll find that on the Economics Center, where you can see on the screenshot here, you just drag and drop the number of servers, and you get an instant summary and also a downloadable report that you can then share with your colleagues and use as a baseline for your own calculations. So, here's an example in here where, you can save, over $200,000 per year running on AWS. So this is just one example of the kind of output that you can get from that TCO calculator. So with that, I'll probably stop. I think it's right on time with a big thank you for everybody who has joined this webinar. Also, please note our AWS APAP marketing email address at the bottom. And I'm just going to check with my organizer here if there are any questions. So just one moment. All right. Okay, so the only question that I can see here is, will this webinar be uploaded and can we get this presentation? So absolutely, we will be uploading this webinar. You can replay it, and when you've registered, we will actually send the link to everybody by next week so that you can access it or send it to your colleagues as well. So thank you very, very much for attending. Apologies for my cold and constant coughing, as well as taking this to the full hour, but I hope you found it useful. And please do let us know if there's anything that we can help to make the TCO comparison easier for you as a customer or as a partner. Thank you very much.